Alright, this is the video lesson for 5-6, parallel and perpendicular lines. So we're going to start with a definition here of what parallel lines are, and we should know that parallel lines are lines that do not intersect. So parallel lines are simply lines that do not intersect. And now we have a couple of things that you need to know about parallel lines, and this will be bulleted here. First of all, parallel lines have the same slope, and the symbol for parallel lines is this, which is just two parallel lines next to each other. So this symbol means parallel lines. Okay, so let's go ahead and get into some of the examples here. For example, 1 and 2, it says write the slope-intercept. It should say write the slope-intercept form, misprint there, of an equation of a line that passes through the given point, not pint, the given point, and is parallel to the graph of the given equation. So we want to write the slope-intercept form of a line that goes through the given point and is parallel to the graph of the equation. Okay, so what we're going to do here is we're going to say, alright, if they tell us that our line goes through this point and is parallel to this equation, well, if we know parallel lines have the same slope, all they're really telling us is that our equation has a slope of -3. So now, all we have is we have what we had in the last section. We have one point here and slope. So we know that this is the information we're going to use. We have the point -1, -2, and the slope of -3. So we should also now remember that there are two different ways you could do this equation. One way I'm going to do over here is to solve for b. So you're going to plug this into the y equals mx plus b formula. Again, obviously our first number here is our x and our second one is our y. So we're going to say -2 equals m, which is -3, times x, which is -1, plus b. And we're simply going to solve for b now. So we should have -2 equals +3 plus b, and then subtract 3 on both sides. So now we have -5 equals b, and we know that if we know our b and our m, we can write our answer being y equals -3x minus 5. Now, that is one way to solve this equation. That would be solving for b. Now, another way we could solve this equation is you could use your point slope form, which we learned in the last section is y minus y1 equals m times x minus x1. And that being because up here we have an x1, a y1, and again our m of -3. So we could just plug this in and say y minus -2 equals -3 times x minus -1. And again, both of these minus negatives we know we're going to turn into just a plus. Minus a negative is plus. So we really just have y plus 2 equals -3 times x plus 1. And now all you have to do is manipulate this equation into slope-intercept form. You do that by first distributing -3. And then last step would be to solve for y by subtracting 2 on both sides. Y equals -3x minus 5. So you can do it by doing the first way we did this or the second way. I don't care which way you choose. Both will lead to the correct answer. So I'd like you to pause the video again now and try number 2 on your own. And we're back, and what you should have first noticed about number 2 is we do have our ordered pair of negative 2, 3, but what is the slope of our equation going to be? Because based on this other line, which I know that my line is parallel to this line, but I'm not real sure what the slope of that line is. And the reason I'm not real sure is it's not solved for y, so I would first have to subtract 6x on both sides, giving me y equals negative 6x plus 4, which then tells me, oh yeah, there's my slope. My slope is negative 6. So m equals negative 6. So again, here's the information you're going to use to solve your equation. Okay, that 1 point and slope. And again, we can do this 2 different ways. I'll show the first way here again by plugging in your x of negative 2, your y of 3, and your m of negative 6 and solving for b. You would say y, which is 3, equals m, which is negative 6, times x, which is negative 2, plus b. So we say 3 equals positive 12 plus b. We then subtract 12. 3 minus 12 is negative 9 equals b. And if we know our b and our m, we can write our answer y equals negative 6x minus 9. Done. There's the slope-intercept form of that equation. Again, the second option would be to use point-slope form, being y minus y1, my y1 is 3, equals m, which we said was negative 6, times x minus x1, and x1 is negative 2 in this case. Again, I'm going to change my minus and negative into just a positive. And again, in this problem, all you have to do is solve for y. So I distribute my negative 6. Y minus 3 equals negative 6x minus 12. I add 3 to both sides. Y equals negative 6x minus 9. And that is my answer. Y equals negative 6x minus 9, just like we got over here. So there you have it. There's our first 2 examples, and that is dealing with parallel lines. Alright, next we are going to look at perpendicular lines, and again we're going to start out with some definitions here. So the definition of perpendicular lines is perpendicular lines are lines that intersect, creating 90-degree, which are right, angles. So they 2 lines that intersect form 90-degree angles is what you're talking about when you're talking about perpendicular lines. Okay, 2 lines that intersect to form 90-degree angles. Again, some bullet points here to know about perpendicular lines. The first bullet point is that their slopes are opposite reciprocals. So perpendicular lines have opposite reciprocals for their slopes. Now, an example of what opposite reciprocals look like would be the opposite reciprocal of 2/3 would be negative 3 over 2. So opposite being positive, negative, and reciprocal meaning switch or flip your numerator and denominator. So another example, opposite reciprocals, if you had negative 2, the opposite reciprocal would be positive 1 over 2, because we know negative 2 is negative 2 over 1, so the opposite reciprocal would be positive 1 over 2. So perpendicular lines have opposite reciprocal slopes. And then the symbol for perpendicular is kind of like an upside down capital T. Again, just simply showing two lines intersecting to form 90-degree angles. All right, let's move on to some examples here. We're going to do these problems exactly like we did the other problems. So in this case, they are telling us that we have the ordered pair -3, 1. Our line goes through the ordered pair -3, 1 and is perpendicular to this equation. Well, if it's perpendicular to this equation, all that tells us is that the slope of our line is going to have the opposite reciprocal of the slope of this line. Well, this line has a slope of 1/3, so that must mean our line is going to have a slope of negative, because that was positive, ours is going to be negative, and then flip this around, 3/1, or just -3. So our slope is -3. So now, again, you'll go through the process of putting it in slope-intercept form, because that's what they're asking for, is slope-intercept form. Again, this can be done two different ways. I'll show both once again. The first way would be to solve for b. So you're going to plug in y, which is 1, equals m, which is -3, times x, which is -3, plus b. And you solve this, this would be 1 equals +9 plus b, and we subtract 9, giving us -8 equals b. And again, as long as you know your b and your m, you can write your answer. So in this case, it's going to be y equals -3x minus 8. So that would be one way by solving for b. Again, our other way, which I will do right here. This would be way 2. So, or we can do method 2 here, which will be point slope form. So we're going to say y subtract y1, which is 1, equals m, which is -3, times x subtract x1, which x subtract -3 turns into x plus 3. And now we simply solve this equation for y, starting by distributing. So I have y minus 1 equals -3x minus 9, and then I add my 1 to both sides. Y equals -3x minus 8. Again, same answer as I got using the other method. Either method's going to be fine. So, again, you can go ahead and attempt number 4 on your own here, and check your answer when we come back. And we're back, and hopefully with number 4 you realized the first thing you needed to do was to solve this equation for y, because you need to know what its slope is before you can determine what your slope is going to be. All I know is that these lines are perpendicular, or your line is perpendicular to this line that they gave you. So I subtract x on both sides, which gives me 4y equals -x plus 12, and then I will divide by 4. And since this is a -1x, I'm going to have y equals -1/4 x plus 3, which again, the only reason I even care about what this line is because my line is perpendicular to this line, or the line that you're trying to write the equation for is perpendicular to this line, and this line has a slope of -1/4, which means the line you're trying to write an equation for has a slope of 4, because 4 is opposite reciprocals of -1/4. So you have the ordered pair -3, -2, and the ordered pair, and the slope of 4. So now you put it in slope-intercept form. This time I'm going to only use point slope form. I kind of like point slope form the best, so I'm going to say y minus y1, so y minus negative 2, which turns into plus, equals m, which is 4, times x minus negative 3, which again turns into a plus, and now I solve. Distribute my 4, y plus 2 equals 4x plus 12. Subtract 2 on both sides, and we should be getting, for our final answer here, y equals 4x plus 10. And there you have it. Now again, you could have done this by solving for b, plugging in your x, y, and your m in for, and then leaving b as b, and solving for b. You should have gotten b equals 10, which would have given you the same answer, y equals 4x plus 10. Alright, and finally we have a couple of kind of application problems, or really just thinking problems here. Number 5 asks you to determine whether the equations are parallel, perpendicular, or neither. Now, again, what that means is that do these two lines, do these two lines, will they be parallel to each other, perpendicular to each other, or neither? Are they just two random lines that are somewhere else? So what you need to remember, obviously, is that parallel lines have the same slope, and perpendicular lines have opposite reciprocal slope. And if it's neither, that just means they'll have neither of those two things. The slopes will not be the same, and the slopes will not be opposite reciprocal. So what you need to do is simply figure out what the slopes of these lines are. Well, the first line here, I'm going to need to first divide both sides by 3, so that this equation says y equals 2/3 x plus 14/3. I'm just going to leave it as an improper fraction because I don't really care about the y-intercept in this case. What I do care about is the fact that this line has a slope of 2/3. So this line's slope is 2/3. Now, the second line over here, I will start by subtracting 2x on both sides. So I have negative 3y equals negative 2x plus 2. And then my last step will be to divide by negative 3. The negative 3's cancel there. Y equals negative 2 over negative 3 is a positive 2/3, so I have positive 2/3 x, and then minus, and again I'm going to just leave my y-intercept as a fraction, so minus 2/3. Again, what I care about here is that this line has a slope of 2/3. Well, that means they both lines have a slope of 2/3, which means the lines are parallel. And again, the lines are parallel because they have the same slope. Alright, very good. And finally here we have problem number 6. Oh, it looks like I erased part of problem number 6. Alright, there we go. So problem number 6 gives you 4 points. It says point A is at negative 2, 1. Right here it says point B is at 3, 3, C is at 5, 7, and D is at 0, 5. And it says to determine whether the segment AC is perpendicular to BD. Well, again, we're talking about line segments here. Points on the graph, points on your XY axis. For instance, A is at negative 2, positive 1, which would be right there. So there would be point A. B is at 3, 3, which would be right there. Okay, and so we're talking about these 2 points being connected, and what they want to know is AC perpendicular to BD? Well, what you simply do here is find the slope of those segments. I'm going to first find the slope of AC by doing the slope equals, and now I go back over here to my ordered pairs and I just do my subtraction like you would finding slope of anything. I'm going to subtract C from A, so I'm going to say 7 minus 1 over 5 minus negative 2, so 5 plus 2. So the slope of AC is, what is that, 6 over 7? So the slope of AC is 6/7. And now I'm going to find the slope of BD, again by doing my M equals, and I'm going to take D and subtract B. Again, you can go either way. I'm going to do 5 minus 3, and then I would have 0 minus 3. And 5 minus 3 is 2 over 0 minus 3 is negative 3. So the slope of BD is negative 2/3. And the question's asking, is line segment AC perpendicular to BD? And remember, perpendicular means that the lines have opposite reciprocal slopes. These lines obviously are not opposite reciprocal slopes, so you would say no, they are not perpendicular because the slopes are not opposite reciprocal. Sorry, I ran out of room there, but you heard what I said. So, no, they're not perpendicular because their slopes are not opposite reciprocals. Simple as that. All right, there you have it. That is all for 5-6.